Hi everyone, so today we're going to talk about graphing rational equations and also identifying key features of these graphs. So remember that a rational function is a fraction. So because we have a fraction, we might have some polynomials or just some constants in the numerator and the denominator. And you need to also remember that the denominator can never equal 0. So a couple of vocabulary words we're going to talk about today: a horizontal asymptote, horizontal goes left and right, and a vertical asymptote, which goes up and down. So these are going to be drawn as a dotted line and not a solid line. Now, these asymptotes that are part of your graph here is just pretty similar to what we talked about end behavior. Now, these are, as your graph sort of approaches let's say a specific number or approaches positive or negative infinity, these are imaginary lines that our functions don't touch or cross. Now, these asymptotes will go between what are called the branches, or your looks like curves of your rational graph, which we'll look at later on in this lesson. Now, some things to remember when we talk about horizontal asymptotes: your graph can have at most one. It could also have no horizontal asymptote. And because horizontal lines are written in the form of y equals, that's how the asymptote equations are going to be written as well. And then the same thing goes for vertical asymptotes, right? Vertical, your graph can have more than one. It could have none. It could have two, right? But the thing to remember is when we write our equation of our line, it's going to be x equals and then a number. Now, with horizontal asymptotes, your graph could cross, so it's very careful for you to look at your graph. But you must remember that a graph can never touch or cross a vertical asymptote. Now, this first example we're going to look at is we've already given you the picture of what this function will look like. So let's just go ahead and identify what these key characteristics are. When we look at x-intercept, we can look at our graph touches right at 1, 0. You also can identify your y-intercept, and that is at 0, and you can put 0.5, or you can write 1/2. Now, when we talk about a horizontal asymptote, we're looking for an imaginary horizontal line, right? So we're looking at a y value that the branches of your graph, so these are your branches of your graph, get very close to, but they don't actually cross. And for what we can do is we can see that our y value of 1 is that value that the branches of your graph get very, very close to, but they don't actually touch or cross. So we can also look at our vertical asymptote. So vertical is a specific x value. So looking at the branches of your graph, gets very, very close to, but doesn't cross or touch, which we have right here at x is equal to 2. So when we talk about domain and range, we are talking about x's and y values. So with domain, we know is x. So we want to know what are all the possibilities of x's that you could have in this graph. So what you can think about is that you have sort of a restricted value, right, that could not be included in your domain. And that would be right where you have that asymptote, right? So your domain would be all possibilities of x's, so all real numbers. And then we just want to be specific at that one value that x cannot equal. So x cannot equal 2. And that is based off of, again, as you probably saw, that connection is based off of your vertical asymptote. Now, when we talk about range, again, we're talking about our y value, so you can probably make that connection too as well, is that there is some y value that cannot be included in your range, and that's also where we have a horizontal asymptote. So you could have all possibilities of y's, so all real numbers, and then y just cannot equal 1, and that gets connected with your horizontal asymptote. With this, the range is the one where you also need to confirm by looking at your graph, right? Because it is possible to cross your horizontal asymptote, so you just have to confirm with your graph. Okay, so in example number 2, we can go ahead and graph this in our calculators, press y equals to graph, press alpha y equals to get your fraction bar, toggle out to get that plus 3 out of the fraction, and then press graph in order to see what your function looks like. So x-intercept we can see from the table is 1, 0, so we'll go ahead and put that here. Our y-intercept is 0 and 1.5. You can see what the vertical asymptote is with the error. And that would be this imaginary sort of dotted line that you have. The horizontal asymptote we can see is at 3. So again, imaginary dotted line there. And then you can see based off of where your branches are, if you just give a sketch going through your points, and then another sketch right here of the other branch. So your domain, again, is going to be based off of your vertical asymptote, so all real numbers. X just cannot be 2. And for our range, you have all real numbers, and y just cannot be 3. Again, confirming with your graph, you do not cross the horizontal asymptote. I hope you found this video helpful and you're able to graph rational functions on your calculator. Don't forget to check out our next video on how to graph rational functions algebraically. Thanks for watching and have a great day.